And we're all set to go. So hi everyone, welcome to the Foreman community demo number 148. I'm Nofar, I'm a Foreman developer, and I'll be hosting today's demo. So let's get started. For any questions or comments, feel free to reach out to us on the Foreman group chat on metrics, or during the demo you can also use the chat here on Google Meet to reach out. This is our agenda for today's demo. So we have 3 demos and 1 update from Ewoud. Yeah, let's get started. I'm the first one. My demo today will be about adding secure boot support for Libvirt. I'll be showing 3 ways to do that. The first one, I'll be showing how to create a host from Foreman, and then it will be created on Libvirt. I will show it using the virtual machine manager. After that, I will do the opposite. I will create a VM in Libvirt, and I will import it to Foreman, again with secure boot enabled, of course. And the last part of the demo will be via Hammer. I will also show how to do it in a quick Hammer command. Okay, so I'm stopping the sharing because this time I would like to share my entire screen. So sorry about the confusion. I'm being a little risky, but I have multiple windows to share. Okay. So as I said, let's start with creating a host from Foreman. I'll go through the steps with you. If anyone has any question, please feel free to raise your hand or speak up. Okay, so I will choose deploy on to use Libvirt. Next, I will go to virtual machines, and basically just for this demo, I want to show that I've created a new firmware option. Actually, let me zoom in. 1 tab, yeah. This is a new one, and for this time, I would like to choose automatic. And if you're not sure what automatic means, you can click here, and it will explain that automatic basically will set the firmware based on the host pixie loader. The default, if no pixie loader is selected, will be BIOS. But right now, I would like to show you secure boot. So what I will do, I will set it to automatic. The rest of the fields I'm ignoring because it's just for a demo. And here, I will fill out the settings that I want. And the important part is this one, the pixie loader. I will choose the grab2 UEFI secure boot. Now, the firmware will be set automatically according to this pixie loader, so I'm expecting it to be set to UEFI secure boot. Great, I have everything set here. You can click on resolve just to make sure you have the right template here. I'll go to interface, and here I need to set some fields. Let's see, my IP is working great. And here I will choose the virtual network type. Okay, I have everything set. I'm clicking submit. And my host is created. Oh, I forgot to give it a name, so I need to remember this one, Irvin something. Let's go to the virtual manager and look for this host. It's here, you can see it's running. Yeah, sorry about that. Forgot about the password. Let's do this, that I don't need any password, and log in. Yeah, and I can see the machine is running. Basically, I'm trying to provision it. So that's going to take some time. For this demo, it's less important. The important part is to show that the firmware here was selected to secure boot. And if you're interested in looking at the XML file, the option that basically enabled the secure boot is what added from Foreman is this 2 features here, the enrolled keys and the secure boot. So basically the enrolled key feature allows the VM to have the keys enrolled for the secure boot verification. And this typically refers to the keys that the firmware will use to verify the integrity of the operating system loader. Okay, let's go back to Foreman. I clicked on the edit host, and I would like to see that the firmware is updated. As you can see, you cannot edit the fields here. That's something that was in Foreman before adding the secure boot feature. You can't edit none of these fields. And yeah, here nothing has changed. So it looks like everything is working and the machine has secure boot enabled. Okay, I will stop this machine. And I will go to the next part of the demo. Again, feel free to ask questions if you have. This time, I would like to create a machine from the virtual machine manager and to import it to Foreman. So I will go through the steps with you just so you can, see. I will choose the Fedora OS. Here, it doesn't matter for me. It's just for the demo. And for the name, we'll give it Libvirt machine demo, let's say. And I would like to customize the configuration before the install. Okay, so here I can choose the firmware type. And because we're demoing secure boot, I would like to choose this one. And click apply. Then I will go to the boot options. And because I want it to boot from network and not from local disk, I will check this checkbox and not the other one. And we're free to go. Okay, so the machine again will start the provisioning process, which is less relevant right now. For this specific demo, what's important again is to see here the firmware that we chose is correct. And I would like to go ahead and import it to Foreman. So to do that, I will go to the compute resources. I need to choose Libvirt, virtual machines tab, and this is the first machine. I need to import it as managed host. Okay, great. You can see that the deployed on is already set to Libvirt. Here under virtual machine, the firmware is already set to secure boot, which is expected because that's what we set from the virt manager. Operating system, those are fields that I need to fill in. The pixie loader, well, let's change it to secure boot. Oh, this one. Let's check that the interface is good. Default, I have IP and virtual network type. Okay, great. I will click submit and I have my host imported from Libvirt. What else I can show you here? I can show you that the XML file is a little bit different this time. If you've noticed, I don't have the features of the secure boot set to true and enrolled keys also set to true, which is completely okay because I created it in a different way. But here you can see that the loader has set secure to yes, which is not enough to enable secure boot. What's important is this part. So this part is the content of this file. That's a binary firmware from the OVMF project, which provides the UEFI support for VMs. And basically, this is the path for the to the UEFI firmware file that includes the secure boot support. Yeah, I think that's it for the second part of the demo. And for the third part of the demo, I hope everyone's still with me. I will use hammer to create a machine. So I have this command here all ready to use. So the important part of this command is just to add this last part, which is in bold, the compute attributes with firmware equals to UEFI secure boot. I already have a host group created with all the other fields. So this is the only field I wanted to emphasize here for you to use if you would like to use hammer to create a machine with secure boot enabled. And I will go to hammer, I will create it. The name of the machine will be a hammer Libvirt secure boot demo. Oh no, failed to create. Oh, I already have this machine. Yeah, probably when I was getting ready for this demo. So, but I don't see it here. Oh, I probably forgot to delete it from Foreman. Sorry about that. Let's see. Okay, so I deleted it from Foreman and from Libvirt, but apparently I forgot to delete it from somewhere. Probably the image or something was not deleted. Oh, actually, I can just use the same command and change the name of the machine for it to work. So I'm adding just one to the name of it. Okay, great. So host created. And I will go here to refresh the host list. Yeah, and I can see here I have a new host. Let's go to the Virt manager. See, yeah, I also have it here. I will run it. Again, I need a password. That doesn't matter right now. I can see the firmware is set to secure boot as expected. That's great. And also, if I will go to edit here, under virtual machines, I see that the firmware is also set to secure boot. So I would like to conclude this demo. I showed how to create basically how we added the support for secure boot in Libvirt in 3 different ways. The firmware option is a new option, so you can use it to create BIOS machines and also UEFI firmware-based machines, not only for secure boot. This feature is useful, and yeah, you can do it via UI. You can import existing machine from Libvirt, and you can also use Hammer to do it in one quick command. Yeah, that is all from me, this demo. I will stop the sharing, and if you have any questions, please speak up. Okay, great. No questions so far. Yeah, so we can move on to our next demo, which is host bootc. I hope I said it right. Yeah, host bootc information in Hammer by Ian. So Ian, whenever you're ready.
Awesome. Thanks, Nofar. That was a great last demo you did. That was pretty cool.
Thank you. Thank you.
Let me get my screen shared. All right, I think this is the right terminal. Cool. All right. So this is going to be a terminal-only demo today. Soon enough, we'll have some cool stuff to show on the UI. So the demo that I'm going to be showing today is kind of the beginning of our integration with image mode hosts. If anyone has seen the blog post that Red Hat put out about this new image mode host style, I would highly recommend you search it and take a read through. You can also look up on the Fedora documentation. They have a great page on bootable containers, which is also related to this technology. Or you can also just read the bootc documentation. The kind of gist of the situation is that these new hosts are OS tree style hosts that get created from container images. And naturally, Foreman and Katello should be able to handle these. So what I'm going to be showing you today is how we're going to be displaying this information on hosts. So I have a bootc host right here. And if I run a bootc status, you'll see some information about the image that it's running. So you can see a version of the image. You can see the path where you could pull it from Podman if you wanted to. So I have this CentOS Stream 9 lamp container image that I've created. This is the basic one that you run through, like in the quick start tutorial that is in the Red Hat blog. But pretty much I've created a container image that installs a lamp stack. And then I've created this machine with it. You can see there's a digest here. So this is all information that people are going to want to know about. If your machine is out of date, this digest might not match the latest up-to-date digest that the tag is following. So then at that point, you would need to do something like a bootc upgrade, which also, by the way, is done automatically, periodically on these image mode hosts by default. Anyway, enough about that. So what's some of this information that you'll be able to see? Firstly, let me just pick a random host here. So there's a number of new fields under bootc image information. You'll see the running image and the running image digest. This host is different from the one I showed over there. This is dummy data that I put in. So you'll see some image path, and then you'll see a digest. Now, there are other fields, and these fields are important. So we have the staged image in digest, we have the available image in digest, and then we have the rollback image in digest. The staged image and the staged digest, that's the image that will show if you are switching to another image. So let's say I no longer want to use this lamp stack image and I want to change to just like a base stream 9. If I ran bootc switch, let's see, I might be able to get this right first time. If I run bootc switch on Quay for CentOS bootc, and then CentOS bootc and then stream 9, it will try to fetch this information, and then it'll show that there's something staged. Now, I'm going to wait and see if this actually happens. But while this keeps going, so the staged image is the one you're about to switch to. The available image, this is one that you have perhaps not switched to, but it's going to be the image that the machine will upgrade to when you run a bootc upgrade. So you can run a bootc upgrade without applying it. So it'll prep the next image, and then if you apply it, it'll reboot into it. If you've prepped this image, let's say this running image is some image with the latest tag. That latest tag will likely change at some point. Since it's the latest one, it'll always point to the newest stuff. As that changes, you'll need to run bootc upgrade to upgrade your system. So that's what the available digest will be. If an available digest is showing here, that means when your machine reboots, it'll upgrade itself. Then we also have the rollback image. If you don't like the image that you switch to, you can run a bootc rollback. This just means that there is a rollback prepped. So at the next reboot, it'll roll back to that older image. Cool. So my machine found something. Let's run a bootc status just so you can see what some of this looks like. So we have the currently staged image, which is the normal CentOS bootc one that I just switched to. And so that will end up showing up here in the staged image section. So you can now see this information in our API and also in Hammer. There's a caveat that I'll share at the end, however. You can also see this on the host list page. These fields are optional because this is quite wordy data. We don't want this, polluting the normal Hammer host list. So you have to set this information yourself with using the fields. And you can set like running image digest. If I do a Hammer host list --help, we can see all the different options. Scroll up here. We got all the options right here. And now there are also search options. So you'll be able to search for all of these. And then you'll also be able to search if it is an image mode system. We are looking for feedback about the naming. In some places, it feels like it makes more sense to refer it to bootc. In some places, it makes sense to refer it to image mode. But there is one important thing. These facts so far are not being fetched yet. The bootc team is still implementing fact fetching. That's going to happen through Subscription Manager. So they're going to create a facts file that Subscription Manager will pick up and send it over to Katello. And the code to start integrating with that is already being reviewed in GitHub. However, we just need to wait for the bootc team to put out their release that has this feature. But yeah, so this is supposed to be a full user story for Katello 4.16, which is not the release that's happening now, but the next one. So yeah, stay tuned for more demos. But yeah, that was it. Happy to answer any questions if there are any.
Thank you, Ian. No questions so far. So I guess we can move on to our next demo by Samir, introducing flatpaks in Katello.
Hey, all right, let me share my screen here. So we are very early on in the process of developing this. So this demo will mostly be on the console, and I'll also introduce flatpaks in general. Let me share my whole screen here. All right. So let's begin with what flatpaks actually are. So flatpak is an alternate way of distributing desktop applications, so to Linux systems. So I'll just show how that looks like. So for example, on Fedora, I have this application GIMP, right? So you now have the option to install it via Flatpak. So you have this registry.fedora project. You have the option to install it via RPM, but starting with some release, I think some of these applications will move only to Flatpak models, and they won't be available as RPMs anymore. So that is why Katello is being asked to support Flatpaks, just like any other content type. So we already have support for Yum. We already have support for containers. And one neat thing about Flatpaks is it can be packaged as containers. So when you install this application, for example, it's pulling content from a container registry. So I'll show what that means. All right, so let's take a look at the Fedora registry. So Fedora registry itself comes with an index. So that index will list all of the applications that are available on the registry for Fedora registry, for example. So if I were to go to my system, what I have here is, so I can do something like Flatpak remote ls. I can do a Flatpak remote add to add any registry to my box, and then I can pull down applications from that registry. And then if I want to look at all the applications that live on that registry, I can do a Flatpak remote ls, and then it will tell me what applications I have available to me. So this is sort of, I have a lot of applications because I added the Fedora registry. It has some 400 plus applications. There's also another registry, FlatHub, which is very popular. The difference between FlatHub and Fedora registry is Fedora packages its Flatpaks in as containers versus flathub.org that packages it as OS tree. So in the context of Katello, we'll be supporting only the Fedora registry and the Red Hat registry, which is built on this, which has fewer apps. All right, so let's see. So if you see my system here, this lists what remotes I have currently enabled. So I have the Fedora project registry enabled, and I have the flathub.org enabled. So speaking in terms of Katello, what we want to do is to allow users to add remotes similarly to Katello. So they'll be able to create remotes that point to, let's say, Fedora registry or Red Hat registry, for example. Those are the ones we are starting the support with. I have an RFE out, which goes over some of these details. So if you look at this RFC, it's called Flatpak Support in Katello, and we go over some of the design proposals we have. So the first step here is to create these remotes. So we are planning to pre-configure some remotes that will be available on your Katello immediately when you upgrade. One of those will be the Fedora registry upstream. So what that means is, so let me switch to my console. We don't have a UI yet. We don't have Hammer yet. So I'm just going to dig into the console. All right. So we have something called Flatpak remotes in Katello. And you can take a look at what I have today. So here, for example, I have a Flatpak remote pointing to the Red Hat Flatpak index. And it also has something called registry URL. So when you actually go to do an install of an application, it will hit this registry endpoint. Pulp also serves a Flatpak index. So the plan is to use this flatpak index for our katello clients. So they will be pointed to the pulp core registry once you have synced some of this flatpak content in katello. All right, and you'll see the registry URL is pointed to my box. So this will use Katello's registry, which proxies it to Pulp's registry. Okay, so what I can dig into this a bit more. So if you look at, let's say, this example registry, we have several repositories here. So you can look at something like Firefox Flatpak, right? And it will have some images. So for example, I have 4 images here. So these are differentiated based on your operating system or your architecture of the machine you're pulling content from. The Flatpak CLI sends all of these as arguments to the registry to know which one to pull, which particular image to pull. So what we have here, so once we have a Katello remote pointing to this endpoint, we can then scan this entire index and pull down all of these repositories into Katello. And these are not actual like Katello repositories yet that you can pull content from. These are just representations of the remote repositories. So what that looks like in the console is these objects. Let me just pick one of them. All right. So what we have here is, so once we have the remote, you can actually scan a remote. We have an action to scan whatever remotes you create in Katello. And what that does is pulls down all of the remote repositories from that index. So for example, we have this rel 8 flatpak runtime flatpak. And you can also look at what images live inside this. So you'll see, so this one has just one manifest. So this is the one which will be pulled down. We don't have all of the information that lives on the index because this is a lot of information, and we will get this information once we sync this content down to satellite to Katello anyways. So once you have these remote repositories, what you can do is have a mirror action, and you can actually create a Katello repository out of this remote repository. So I'll skip that action, and I'll just look at one of the mirrored repository. So what this does is, so this is an actual satellite Katello repository. Let's see. So this will live under a product in Katello terms. So I have a product here, flatpak repositories, and this will have an actual mirrored repository, which has been mirrored from one of these remotes. This will be pre-populated with all of the repository details you need. So like the upstream URL, repository name. If it's an authenticated registry, you'll need to provide your username, etc. And one thing to note here is we'll always limit flatpak repositories to the latest tag, because that is how it's meant to be. You can only always be on the latest tag of latest version of the application. When you install that application, you cannot provide like a tag to point to some older version. These the images that are tagged by the latest tag might change, so that is how you update. So the next time you try to update, it will look at the image digest for the latest tag at that point in time, and it will pull down that image. So yeah, so this is like the Katello repository, and once you sync it, you'll be able to see all of the content that you would usually see in a container repository. And once this has been synced, you can also take a look at the flatpak index that Pulp is serving. And then you can point your client to that index and start consuming this content. So in this case, you would be able to do a Flatpak install, Firefox, for example, while being pointed at pulp registry. Okay, so for now, I have just this, and hopefully we'll have some Hammer and UI updates soon in future demos.
Okay, thank you, Samir. I don't see any questions. So we can move on to our next demo. Oh, we came to Ewoud, Performance's open source plans. Ewoud, whenever you're ready.
Yeah, I don't really have anything to share in terms of screen, so I'll just going to talk. By now, I expect a lot of people have seen Perforce's blog post. I also linked to the demo. And I think it's good that we, as the Foreman project, at least form an opinion on this. And I think I'm in pretty good position to form an opinion on it. I've been a very long time Puppet user. I started around Puppet 0.25, way back. People will also probably know that I maintain or co-maintain the installer, the Foreman installer, that uses Puppet to apply things. So it is critical that in our current pipeline. And my interpretation of Perforce's plans is basically they are going to close the source. They will still publish a source, but you need end-user license to sign end-user license agreements to actually get to the binaries. You might even need to sign the same thing for the gems, which can be very blocking for us. At this point, I will say I'm aware of, or we as a team are aware of it. We're looking at the options. Currently, there's still a lot unclear. The whole exact text of the end-user license agreement is still not there, but there is a community effort starting, which I will also add to the community demo page, which will have published packages as well. And my expectation is that we will switch to those because they can be freely used, free as in money-wise, but also free as in open source and all the licensing-wise. So please stay tuned, but I just wanted to sort of share that this is very much ongoing and we're trying to deal with it as best we can. I will also make a Discourse post summarizing the same thing I just said, but it's very much a developing situation. So I'm sure there are questions, maybe not now, but maybe later. I'll be happy to at least give my opinion on it. So if there's nothing else, then thank you.
Thank you, Ewoud. I don't see any questions. And thank you for sharing the links in the community demo page. Okay, so I guess we can conclude this demo for today. I would like to thank everyone for joining. Our next demo is on December 5th. And yeah, thanks for all the presenters for today. Great session this time. See you all next time. Thank you.